Okay, so on this one, we're saying how many different arrangements can be made using all the letters in each word. So we're trying to arrange the letters in the word Yukon. So first off, so clearly here, order matters. I mean, that's the main thing that does matter, right? Order matters. So what does that mean when order matters? Why does that matter? To use the word matter twice. From the notes, exam 4 notes, when order matters, we'll get to some in a minute where the order does not matter. But for now, order matters. What do you do? When the order matters, it's about options and decisions and options, isn't it? Right? You take each decision and you write the number of options for decision 1 times the number of options for decision 2 times the number of, et cetera, et cetera. It's decisions and options when order matters. If order doesn't matter, you do something different. But this is clearly order matters. So I'm going to be all about decisions and options. Okay. Specifically, I'm going to add to the notes for you a formula for letter arrangements. And here's how it's going to go. In fact, maybe I should, let me just put it right down here. Formula for letter arrangements. It's going to be total letters, total number of letters, total number of letters, factorial, remember the exclamation point is factorial, over repeat letter, factorial, and then repeat factorial, etc. Just like that. There's the formula for letter arrangements. You put the total on the top with an exclamation point, meaning a factorial. I'll remind you how that works. And the repeats on the bottom. So for Yukon, we have 5 letters. So it's going to be 5 factorial, and we don't have any repeats, right? There's no repeated letters. We'll get to repeats in the next one. No repeats. So it's just 5 factorial. It's just 5 times 4 times 3 times 2 times 1, which is some number. We all have the exact same question on this one, 120. Now you might be going, well, Mr. You said it was decisions options. Yeah, it is. It's really decisions options that led to this formula. Let me show you. If you could have done it by decisions options, like let me do an example. Let me pick one. So I could go K N U O Y. So I just picked some arrangement of the Yukon letters. How many decisions? I made 5 decisions. 4, 5. Right? Decision 1, decision 2, decision 3. Decision 4, decision 5. How many options did I have? I had 5 options for the letter that comes with. I chose K. Times, then I had 4 options for what comes next. Times 3, times 2, times 1. See, it's the same thing, isn't it? See, it's 5, 4, 3, 2, 1. That's where that formula comes from. It's decisions, options, thinking. So I wanted to show you that they're in alignment. They're saying the same thing. Decisions, options, or this formula, same thing. Now, it gets a little more tricky when there's repeats. See right here, I think we have 7. Yeah, 7 letters. 7 letters. But A repeats twice. Right? A is a repeat. Now, don't worry about uppercase, lowercase. You might think, well, yeah, but it's upper, lower. It doesn't matter. We're just saying they're all A's. No, it's not case sensitive. We're ignoring case. A repeats twice. So what does that mean? According to the formula right here, you put the total on the top, 7 factorial, 7 letters total, right? Total on the top over the repeats. So we have just 2 factorial on the bottom, 1 repeat. So what's that going to be? 7, 6, 5, 4, 3, 2, 1 over 2, 1. And the easy way to do this problem is just to cancel 2, 1 and 2, 1. And so it's just 7 times 6, 5, 4, 3. And I'm getting 25, 20. When I multiply those together. Does that make sense? So when you have repeats, you've got to divide by that factorial for the repeats. Now, if you're wondering, well, how does that do decisions options? That's a little tricky. It's because you're dividing out the ways to mix those up. I'd be glad to talk more about that with you in office hours if you want to see why that formula is true. Reach out to me. Be glad to do that with you. Let's do the next one. So how many letters we got here? 1, 2, 3, 4, 5, 6, 7, 8. I think it's 8. 1, 2, 3, 4, 5. Yeah, 8. How many repeats? We got A and A. Is that it? Yeah, I guess so. So it's just going to be 8 factorial over 2 factorial, which is 8, 7, 6, 5, 4, 3, 2, 1 over 2, 1. 2, 1 cancels 2, 1. So it's just 8, 7, 6, 5, 4, 3. And I'm getting 20,160. And then we come to this one, Saskatchewan. How many letters is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 12. 12 letters, so we're going to go 12 factorial over. Now, how many repeats do we have? We have like A and A. Oh, and A. 3 A's. 3 A's. Couple S's, don't we? Okay. S and S. Nice. Two of the S's, 3 of the A's. And anything else? Get 3 A's. Let me cross these up. Get 2 S's, 3 A's. Guess that's it. I'm missing something. I think that's it. Okay. So how do we actually work that out? Well, that's going to be 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 over. And then what's on the bottom? Well, 3, 2, 1 and 2, 1, right? 3, right? Because it's 3 factorial and 2 factorial. 3, 2, 1 and 2, 1. All right, so cancel what you can. 3, 2, 1 and 3, 2, 1 cancel. And so then just multiply what's left over. So 12 on down to 4. I'm getting a very large number. 7, 9, 8, 336 over 2. 2 times 1 is 2. Okay, and then divide that by 2. And I'm getting an answer. Final answer. I'm running out of room here. It equals 399,168,00. 39,916,800. That's how many ways you can reorder the letters in the word Saskatchewan. 39 million different ways to put in order. It's amazing, isn't it? How many different ways there are to do that? To put in order the letters in the word Saskatchewan. So there it is. There's the formula for letter arrangements. It's just total letters factorial over repeat factorial in the denominator. Then just write them out, cancel what you can, use your calculator to get the answer. It's the same as decisions options, really. There we go.